Morning guys. So last week I got you to watch a video and read all about friction and force. So today we're going to clarify it for you, make it a little bit easier and understand the equation. So what you should have known from the information last week is that there's two types of frictions. One is static friction and the other is kinetic friction. And what does that mean? Basically, static friction is what keeps the object from moving without being pushed, and it's present when the object's not moving, okay? If the object's not moving, then that's static. The moment it starts moving, it becomes kinetic friction, okay? So it's a force that resists the movement of the surface when the object is moving, and it exists when it's in motion, okay? So a quick example, okay, I've got an eraser here and a whiteboard. Flat here at the moment, static, okay? It's not moving. I have to lift it up, lift it up, lift it up. Static friction is what is keeping this eraser from moving, okay? The moment it starts moving, kinetic friction's there from making it go faster, you know? There's like little bits of molecules in between these two surfaces. Okay, that might look flat. The surface is not flat. There's tiny molecules of bumps stopping it from moving. So the resistance friction is what is stopping that from moving. Okay? It's called kinetic. Okay, now you were shown an equation. That equation is friction equals the coefficient of friction and newtons, okay? The force. And that is easy. We can break that down. We know that. We've done that before. What this is mass times gravity. Mass is the weight of the object, or the mass of the object, not the weight. So the mass. And G, gravity, is 9 on Earth, 0.8 meters per second squared. So that is easy. As soon as we've got that, we can calculate the force of the object. This here, the coefficient of friction, you don't need to worry about that. You don't need to figure that out. It's already been done for you. And there's a table of coefficients of friction. And so I'll give you an example. Here, if you look at this table, coefficients. This is when it's static, and this is when it's kinetic, so when it's moving, okay? Wood on wood. When the wood is not moving, it has a coefficient of 0.5. When it starts moving, the coefficient drops to 0.3, okay? Ice on ice, it's really low coefficient, it's 0.1 and 0.03. Okay, so if you just compare these two numbers, what you can see is the coefficient of ice is really low, which means it's going to move quicker. It's slippier. So there's less friction stopping it from moving. Less molecules difference between them, okay? So that's what that's all about. So if I asked you to calculate the static friction of a piece of ice on ice, and you knew that that piece of ice weighed 2 grams, it would be easy. So this is what we don't know. Okay, we do F, or we don't know it. Ice on ice, and it's not moving, is 0.1. 0.1 times, and I told you it was 2 grams, 2 times, so this is part here, 9.8. Okay, so made it a bit clearer for you. It was a bit dark with the reflection. So 0.1 times 2 times to the 9.8. So that would be 0.1 times 3.92. 39.2, sorry. So 39.2 times 0.1, and that gives us the force is 3.92. Done. Okay, do you understand?